Here I am discussing first law of thermodynamics with respect to isobaric process, how that it changes. Isobaric process. Bar means pressures are unitaries. Okay. Isobar means P constant. So isobaric process means pressure going to be constant, then delta P equal to 0. This is the first law of thermodynamics. I am applying here that expression dQV equal to du plus PdV. Now du means I can write U2 minus V1. Then PdV, dV nothing but difference in volume, V2 minus V1. Now we are rearranging this equation. U2 plus P into V2. I'm taking all positive terms and negative terms. I hope you have to know that one already. H equal to U plus PV, sir. This is called enthalpy. This is enthalpy. Delta H means enthalpy change. Now you can write this H2, this is H1. Plus dq at constant pressure. This is at constant pressure, isobaric process pH. So delta Q at constant pressure we call delta H. This is enthalpy change. Whatever I am supplying heat energy at constant pressure equals to its enthalpy. What is the enthalpy first? This statement: the amount of heat energy supplied to the system at constant pressure equal to the enthalpy of the system. So we know that one. Every system has some energy that may be kinetic energy, potential energy, and different forms of energy. If I am measuring that energy at a constant temperature and pressure, that's we call enthalpy. Every system have its own energy. If that energy I am measuring, the system energy in terms of a constant pressure and constant temperature, that is we call enthalpy. The enthalpy also one of the energy of the system, but we are measuring at constant temperature and pressure. So this indicates function of temperature and pressure. So H equal to U plus PV. This is the enthalpy. So you can write differentiate both sides, and I can get delta H equal delta U plus P delta V delta P. But at constant pressure means dP0 delta P. Then you can write delta H equal delta U plus PD. And we can write PV equal to nRT. We are differentiating here. P is constant, you know that one, delta V. R and T also constant. Already I mentioned here at constant temperature and at constant pressure. So here R anyway constant, then which is the changing, sir? Here only delta N. I wrote here G, sir, one symbol. We observe that one G indicate gas state. So delta H equal delta U. In place of P delta V, I can write delta Ng. Delta Ng equal to gas state number of moles of product minus gas state number of moles of reactant. For example, you can write N2 plus 3H2 gives rise to NH3. Assume that one all these are gas state. Then what is the delta Ng for this reaction? N products minus N reactants, but all are gas state. All these are anyway gas state. N product is 2 moles, N reactant is 3 and 1 mole here, total 4. Then I can get it here minus 2. Delta Ng value is minus 2. So we have problems based on this. We'll discuss next class. Okay. And characteristics of enthalpy, you should be know that one. It is an extensive property. Extensive property means mass dependent property. If mass changing, enthalpy of the system also will be changed. It is a state function. It depends upon only state, initial state and final state. It doesn't depend upon how we are achieving that point. A to B, suppose we are moving. How we are approaching that doesn't depend. All the processes have same thing. Exact value of delta H we can't calculate, but we can calculate delta H. H we can't calculate, exact enthalpy calculate because internal energy of the system we can't calculate. So this depends upon internal energy. Delta H equal to delta U P delta V. So whenever you are not able to calculate delta U, then you can't calculate exactly delta H value. Thus we can calculate only change in enthalpy. So delta H equal to positive endothermic reaction, delta H is negative exothermic reaction. These are the some of the characters. I will discuss the remaining things in next class. Thank you very much.